So it's been a while. The audio doesn't work. Seems like it's been a while that I didn't study much for especially for streaming it. Uh, it's because um, a little bit of yeah, depression, I guess. But anyway, um, so even though I got some depression and I didn't do much for streaming it. There are a little bit of progress doing the stuff. So I've finished the domain driven design lecture, and now I'm in the third lecture. So let's keep going. Uh, which of the following are characters of a monolith? Single shared database, of course, because we want to have a one database connection using in every load inside of the program. So we've got one single shared database. Teams operate independently. No, teams should be connected to each other. So because they need to have some synchronization for the monolith. Communicate using asynchronous method calls. Communicate using asynchronous method calls. It doesn't need to be asynchronous. Um, it can be very synchronized calls, so I can get the result right away from the inside of the code. Deep coupling, yes. Because all things just happens at one time, which means this one is related to something else, while the other one is related to this. So deployed as a single unit, yes. Okay, got it. Monolith scaling. A monolithic application is scaled using which of the following techniques? Multiple copies of a monolith are deployed in a ring. These monoliths communicate with each other using chatter protocol to ensure consistent state. Doesn't make sense. The monolith copies are very isolated and then they don't communicate with others. The monolith is broken into separate systems, each of which is deployed independently. Um, a single mastering instance is deployed along with the several slaves. And this allows the load to be distributed between the slaves. Multiple copies of the monolith are deployed, relying on the database to maintain consistency between them. I have a little bit of a doubt for this question, but basically, um, if it can be broken, it's not a monolith anymore. Multiple copies of a monolith are deployed in a ring, which means it's connected, which is not single master interface. So those have a master-slave relation between them. What for? So if it is monolith, there shouldn't be master or slave. It's only just one component working everything. So I guess this is the answer. Communication between instances. True or false? Communication between instances of a monolith typically happens through the database. Between instances of a monolith um, typically happens through the database. So I I sure it is true, but because it is a true-false question, I'm gonna double check with the script. So um, uh, let's check communication. Uh, all of the dependency, all of the communication between monolith instance happens in the database. So the database provides consistency between the instances because while every single instance is working, they are looking at the same database, so they can understand what is actually happening as a status or as a configuration or as for the other components. So the answer is true. Advantage of a monolith. Simple consistency model because I can just copy and paste a single monolith program or folder if it is deployed that way. Then I can easily manipulate to keeping working it. Single deployment process. Yes. Actually, this one is what I have said. Simple consistency. Because if you are updating one monolith program, it might be changed at one point and then made some changes. So we went through here, and then there are some changes here. So we go to here again. So some changes here and go following. So every update is very simple. Nothing could be complicated. Uh, Nothing to monitor. It should be monitored because I don't know. Even whether it is a single or multiple monolith or microservice, it should be monitored. So I don't check this one. Flexible scalability model. No, because it's a single monolith, if you're trying to make it bigger, then um, its ability is no. I mean, its occupation is over the system. Then there is no way to install it. You only should have the bigger machine to install that system. So no. Um, Strong coupling. Strong coupling. I'm not sure if it is an advantage. Strong coupling. I would check this one. Easy cross-model module refactoring. Less. So I think these two are obvious to be a advantage of the um, monolith, but I would check one more time. So here is the advantage of a monolith: easy cross-module refactoring, easier to maintain consistency, single deployment process, a single thing to monitor, a simple scalability model. Wow, that was a simple scalability model? How come?
Again, the database acts as your consistency boundary. So as long as your database supports consistency,
Uh-huh.
then your application will support it. And so this is very easy to maintain a consistent data set. You can always guarantee, for example, that if you write some data and then don't make any other modifications, you'll be able to read that data back. So it's very easy to maintain consistency in a monolith. You have a single deployment process. So when you want to deploy, yes, you have this big bang style release, but you're only doing it once with one thing, and everybody knows how to do it, or at least
Mhm.
a few people are going to know how to do it. You've only got one thing to monitor, so you just need to know, is your monolith running? I suppose you also need to know, is your database running? But from an application perspective, all you're monitoring is the monolith. So there's one thing to monitor, one approach to monitoring it. That's very, very simple. And it has a relatively simple scalability model. So again, the scalability model is just deploy more copies of it, um, and that's fine. So what are the disadvantages? It obviously has a lot of advantages. I mean, if I look at this, I say, hey, that all sounds really good. Why wouldn't I want that? Well, let's talk about what the trade-offs are. So we're limited by the maximum size of a single physical machine. Because of the nature of a monolith, as that monolith grows, it's going to occupy more memory, it's going to need more CPU, it's going to need more system resources. Eventually, it can grow to the point where it doesn't fit on the physical machine that you've got. And then why wouldn't I want that? Well, let's talk about what the trade-offs are. Relatively simple scalability model. So again, the scalability model is just deploy more copies of it, and that's fine.
Oh, so which means as far as it is flexible. So that's different. Simple scalability model is different from flexible scalability model. I would guess it is simple, but it's not flexible. So strong coupling. It doesn't mention about the coupling, but yes, cross-model refactoring is easy. So I would guess that those three are the answer. Yes. Failure is in a monolith are isolated only to that instance of the monolith. We don't have to worry that the failure may affect other instance. Ah, failure. Uh, let's check. I think it's true, but it because we are sharing the database, and then one database failure can cause and if I can affect to some other um, applications as well. So I guess I just want to double check the answer. Monolith isolated only to the instance of the monolith failure. Serious failure in one component often bring down the whole monolith. So what will end up happening is you will have a particular failure, the monolith will go down, but then when one instance of the monolith goes down, it redistributes the load to the other instance. Only they can't handle the load either. This part is somewhat hard to understand. Serious failures in one component often bring down the whole monolith. Yes, in this case, it is talking about the component, not about the monolith. Failure of a monolith are isolated only to that instance of the monolith. So it is not. So this part, serious failures in one component often bring down the whole monolith. Particular failure, the monolith will go down. Um, but then and when one instance of a monolith goes down, it redistributed redistributes the load to the other instance. Only they can't handle um, cascading failure. and the load either. Okay, so this is a bit different scenario, I guess, than what I am trying to understand. But what is happening is that if you if you cannot control one issue, your clone might not control that issue either because they have the same capacity, uh, which is a similar situation happens. So I would guess it's I mean false. Disadvantages of the monolith. So go back to the again advantage.
Single physical machine. Because of the nature of a monolith, as that monolith grows, it's going to occupy more memory, it's going to need more CPU, it's going to need more system resources. Eventually, it can grow to the point where it doesn't fit on the physical machine that you've got, and then you need to get a bigger physical machine. And as you continue to grow, you can eventually hit the point where you actually can't get a bigger physical machine. Or the other factor is big physical machines are often more expensive than small physical machines. So you'll end up with a cost issue with it as well. As you go to these bigger and bigger machines, they become more and more expensive. It also only scales as far as the database will allow. So yes, you can deploy multiple copies of the monolith, you can put them on multiple machines in order to continue to scale up, but often these are relying on a relational database which probably only runs a single instance in order to maintain consistency. You might have multiple instances, but there's often a master-slave sort of scenario. And because of that, that master only scales to a certain point. Again, it's limited by the size of a single physical machine. And so you can hit that limit and then you have a problem. And if you're wondering whether that can happen, whether you're ever going to hit the situation where your database is going to run out of system resources, I can tell you it does. I've worked with clients that have hit that point where they're going, we cannot add any more load to this database because it will fall over and we can't get a bigger machine. So that does happen. Components must be scaled as a group. So even though certain components of your application may require less resources, it doesn't matter. You have to scale everything at the same time. And as a result, you may have unnecessary use of resources. The deep coupling that we talked about leads to inflexibility. Because you have everything depending on everything else, often through the database, it becomes very hard to modify things. For example, you want to change the structure of a table because you've realized that it's kind of inefficient and there's probably a better way to restructure it for a particular use case. The problem is there's a bunch of other things that are also accessing the data from that table. And so it becomes hard to make that modification because even though it may be more efficient for one thing, it may be less efficient for something else. And at the same time, you now have to track down all of those usages of that database table.
So limited to relational database with consistency guaranteed. Because it's a simple, the consistency model is simple, so I guess the consistency is very strong, limited by the scalability of the database. It is about the database, but it's not. It doesn't need to be relational database, so I won't check that one. Inflexibility due to the deep coupling, correct. Limited by the size of the single machine.
In this course, we are going to use a case study that we call the Reactive Barbecue. Now, the Reactive Barbecue is a restaurant that focuses on traditional barbecue flavors with a bit of a spicy punch. it started out as a mom and pop shop and eventually started to grow. They, would have opened up a couple of other locations. Then they maybe moved into a few different cities. Then they were moving across the country. And now they're at the point where they've actually gone global. They're sitting at over 500 restaurants worldwide in a number of different locations. Of course, as the restaurant grew, they had to have software grow with it. When they were a simple mom and pop shop, they probably didn't even use software. But now that they're at 500 locations worldwide, software is a big part of their business. What happened though is because the restaurant really kind of grew organically and the software grew organically with it, they just sort of bolted things in different places to the point where they now have one application that does a number of things. It does everything from inventory management to menu pricing to deliveries and online orders and reservations. All of these have been lumped into one system. And what they're finding now is that they're finding that that system is really struggling under its own weight. They have a lot of legacy processes involved with that old system. And some of those legacy processes require the system to be brought down for a period of time. When, of course, the system is brought down, it means that they can't do things in their restaurants. So they need to try to target that downtime to periods that are not busy in their restaurants or when their restaurants are closed. That was okay when all of their locations were in North America. But as they've gone global, it's become harder and harder to find those periods of time where they can have downtime. So now they're looking to reactive architectures to try to help solve that problem. They're looking for a way for them to provide systems that will be responsive at all times. We're going to use this as a way to drive out some questions about reactive architecture, not just in this course, but in the other courses in the LightBend Reactive Architecture training path as well. So we'll continue with this idea throughout all of the courses that we're going to present. The original reactive barbecue application was built in a monolithic style. In this section, what we're going to do is we're going to take a look at a very specific part of that old monolith. And specifically, it's the piece of the monolith that exposes information for the delivery drivers. We're going to have a look at that. And what we're going to find out is that in that old system, they were encountering a number of problems. What we want to do is we want to try to figure out what are the cause of some of those problems. Why were they encountering them? And maybe eventually we'll start to look at how could reactive architecture have made that better. For now, though, we're just going to look at the problems and their potential causes. We'll worry about solutions a little later in the course.
So the monolithic barbecue, load balancer, deliver controller, order controller, delivery model, order model, customer model. To support all areas of the business, including the delivery drivers. When a delivery driver goes to make a delivery, they need certain information. The information includes the details about the order and details about the customer, among the things. The information is retrieved through the delivery model as indicated in the diagram. So delivery model is here. The delivery model makes a query to retrieve information from both the order tables and the customer tables in order to present the correct view for the driver. If we were to make a change to the database table for orders, which of the following models would be potentially you need to edit? So while the delivery model is separating, uh, 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 looking at the order and customer table, um, if you are to make a change to the database table for orders, which of the following models would we potentially need to edit? Auto model. Because I changed the auto model, the delivery model should be changed as well. Because I'm editing the model, then the delivery model is now got the changed format of the order table or order model, then it need to be changed. Order reports, management predict, uh, periodically runs a report that aggregates information of different orders. These reports give them an idea which menu items are being ordered more often. They use this information for planning future menus and promotions. Recently, it has become clear that while these reports are running, parts of the system seem to become unresponsive. Specifically, the delivery drivers seems to experience more problems with the mobile application. The most likely cause of these issues is consistent coincidence, poor cellular reception. The reports are flooding the network with too much data, resource contain, uh, contention contention, resource contention of the order table in the database. I guess for cellular reception because it happens delivery drivers seem to experience more problem with the mobile application. Huh. Resource contention on the orders table in the database. Whereas management periodically runs a report that aggregates information on the different orders. These reports give them an idea which menu items are being ordered more often. They use this information to planning future menus and promotions. Recently, it has become clear that while these reports are running, part of the system seems to become unresponsive. Oh, sorry. If it is a cellular issue, then it should happen every time, but because it's running it becomes an responsive only when the report is running, so it's not the procellular reception. The reports are flooding the network with too much data. Resource contention of on the orders table in, I guess this one, the reports are flooding the network with too much data. uh, Resource contention on the orders tables in the database. What's the meaning? Resource contention on the table on the Uh, uh, Updating the database contention, resource contention on the orders tables in the database. Yes. So while it is trying to use the resource table, orders table, it also try to access to the resource table. Okay. Usually, this is not a problem because uh, never mind. Um, I was so stupid. Recently, the team working on reservations added a new field to the customer table. This field allows users to specify a preferred restaurant location for their reservations. The addition of this new field required the execution of a database script that locked the customer table. During this period, the delivery drivers were unable to use the mobile application to retrieve the orders. Management probably, sorry, recently the team working on reservations added a new field to the customer table. Customer table. Customer table. Uh, Added a new The field allows users to specify a preferred restaurant location for their reservations. The addition of um, this new field required the execution of the database script that locked the customer table. During this period, the delivery drivers were unable to use the mobile application to retrieve their orders. Why were the delivery drivers impacted by a change in a reservation data? The delivery model wasn't built to the database script put pressure on CPU, which slows down the delivery system. The system experienced the long GC pause, which prevented the mobile application from reaching the server. The delivery model released on the customer table, so it was affected by the table lock. Delivery model release. The delivery model wasn't built to support the new field, so it was unable to query the customer table. How could this have been prevented? Uh, Isolating the new field in an independent table, not used by the delivery model. Inform the driver about the potential downtime so they can print out their orders ahead of time. Avoid locking the table. Executing the script during a maintenance window. Um, the database script put the pressure on the delivery model and delivery model releases on the customer table relies on the customer, so it was affected by the table lock. It's not easy to avoid locking the table. Uh, Drivers. So if it is not an answer, this one shouldn't be the answer. Isolating the new field in an independent table, not not used by the delivery model. The database backing our application has provided to be unresponsive. The operations team has analyzed the server and discovered that there is a lot of contention for disk. It turns out that the orders portion of our system does a lot of reads and writes to the database, sometimes multiple reads writes for a single request, and optimizing it will take a significant investment of resources. Other parts of the system, um, we could mitigate this problem by deploying the order service to its own hardware, indicating how to solve the issues in general, and if it is an answer, updating the hardware or software. It is not the software area territory. So I guess the other three would be the answer. Deploy another replica of our database. Wait a sec. The database backing our application has provided to be unresponsive. The operation team has analyzed the server and discovered that there is a lot of contention for disk. Yes, for disk. It turns out that the orders portion of our system, there's a lot of reads and writes to the database. Sometimes workflow we then write the database optimizing the best of resources. In the meantime, the contention for disk is resulting in poor performance in other parts of the system deliveries. Customers deploy the order service to its own hardware. If it is an answer, how about the data read and write? Uh, can it be the answer to make another replica of our database? But if I do make it, how about the relationship between the this one and this one? Because the two system is connected to the one database, and then it is just running on this database. If I just make a copy of the database on the other side, then while it is updated this one at the start in the beginning, it should be the same, it could be the same, but what about the differences will come. So copies of the application. But this one doesn't make sense, and this one. So in an effort to mitigate the contention for the database, the development team has decided to introduce an in-memory cache in the application. Each copy of the application will maintain a list of all active orders in memory, and they will be unloaded from memory once the order is closed. This will reduce the number of times we have to read from the database. They have implemented and deployed the cache, but now they are finding that application no longer fits into available memory. It turns out that other parts of the application have also implemented caches in various places, and the combination of all the caches is simply too much for the system to handle. Possible solution to the memory problem: increase the available memory of the system. At all. I lost two questions. So sad. What can I do? Progress. So I lost two answers out of maybe 10 questions? How come it's so high like this? Unexpected? Haven't I finished the third reviews as well? Monolith. Introduction. Introduction has no question stuff. Okay, fine. The review question here. The review question here. Yeah, this one seems not correct. I was finished three courses. Now it is only showing until the review 4. Oh, this case study. Okay, I've got two reviews with a good enough score, but I couldn't get this one high enough. Okay, I just confused. No way. Microservices.
When we talked about monoliths, we saw that one of the ways that you can improve the monolith situation, rather than having a large ball of mud kind of scenario, is that you can introduce an additional isolation. And you do that by separating your monolith along clear domain boundaries, usually in the form of different libraries for different areas of the domain. There's another way that we can introduce additional isolation, and that's using something called service-oriented architecture. So with service-oriented architecture, each of those domain boundaries, each of those libraries represents what we call a service. And so you can see here we have an order service, a customer service, a reservation service, and a menu service. The idea with service-oriented architecture is that those services don't share a database. Each service will have its own database, and anybody who wants information about that service has to go through the service's API. They're not allowed to go directly to the database. So for example, in our reservation service, we might need customer information. Now, if that's the case, we can't go directly to the customer's database. What we have to do is we have to go through the customer API. We have to communicate directly through the library, and then that will provide us information rather than going to the database. Now, what this does is it creates additional isolation, because now each independent service can have its own database. It doesn't even have to be the same type of database. For example, in this case, we see that orders is a relational database, but customers is using some sort of NoSQL database, maybe Cassandra or MongoDB or something like that. So now we can actually create additional isolation in that sense. And the other thing is there's now no coupling between the different parts of the application and the database. So the reservation system isn't coupled to the customer's database, which means that if we want to modify the customer database in some way, we want to change the table structure or something like that, we're free to do so. And the only thing we have to worry about is the customer's service. We don't have to worry about the reservation service and how it accesses that data. So this reduces the coupling. Now, some people will say that service-oriented architecture is just microservices. It's just another word, so why do we need that other word? The reality is that with service-oriented architecture, it doesn't talk about deployment. So while it talks about the fact that services don't share a database, they have to communicate through their APIs, it doesn't say how they can be deployed. As a result, some people, when they build using service-oriented architecture, they build it in a monolithic style like we've drawn here, where they still deploy all of those services as one application, but then those services communicate through some clearly defined API. On the other hand, some people choose to go the other route where each service is deployed as an independent application, in which case it more closely resembles microservices. So it's true that if you are in the latter case, if you are deploying each of your services independently, then there is very little difference between service-oriented architecture and microservices. But if you're on the other side and you're deploying things in a more monolithic approach, then there actually is a fairly significant difference. And so we're going to say for now that service-oriented architecture isn't necessarily the same as microservices, although in some cases it may be. And then from there, we can start talking about, well, what makes it a microservice?
Okay. So it was not an easy question again, but at least service-oriented architecture review. True for us, a key principle of system-oriented architecture is that services don't share a database. No, the more principle is when accessing to the database, it should have used the um, service. Should have used the service. So, for example, um, is that those services don't share a database. Have its own database. Anybody who wants information about that service has to go through the service's API. They are not allowed to go directly to the database. So, for example, in our reservation service, we might need customer information. Now, if that's the case, we can't go directly to the customer database. True. In a service-oriented architecture, if one service needs access to the database and access to data from another service, it can request the data by making an API call to the service that owns the data. Which of the following are true for service-oriented architecture? Services much live on the same physical machine. Service may be deployed as a single unit. Service may be deployed independently. Services may share a database as long as they never write to each other's tables. Uh, Read this, okay. Service endpoint must be implemented with the HTTP protocol may be deployed as a single unit. Services may must live on the same physical machine. I think these two. Semi relation to microservices. We can characterize the relationship between service-oriented architecture and microservice by saying service-oriented architecture is a subset of microservices. Some microservice systems are built using SOA. Microservices and service-oriented architecture are different names for the same concept. Microservices and service-oriented architecture are unrelated to each other. Microservices are a subset of service-oriented architecture. Some SOA systems are built using microservices. So this one can be the answer. Service-oriented architecture is a subset of a microservice. Yay! I got all.
We started.
Okay. Uh, let's finish it here. It's already 2:30.